Cool. Up in North Wales. So if you're not listening to us, you're missing it out.
Yeah.
Nice casual chat.
But yeah, it was really good.
Excellent. We're live. Go Latch.
Awesome. Welcome to Space Door Live, the Space Door Roundup, your fortnightly update on the latest and greatest space news. Hi, Nick and Terry. How are you doing?
We're good. We're good. We're going to have a hot one tonight.
It is going to be very interesting. So without further ado, I'll hand over to you. Just a reminder to everyone tuning in on YouTube, if you have any questions, please do leave them down in the comment section below, and we'll try and get to them at the end of the show. I hope you guys have a good one.
Cheers. Well, without further ado, our show got completely rewritten yesterday because of what was one of the biggest news releases of the year, I'd imagine. So David Bowie got it wrong. He was out by about 58 million miles. So whilst there's 3 spacecraft heading towards Mars right now from the UAE and the USA, etc., which we've talked about in previous shows, a team led by Professor Jane Greaves at Cardiff University, and some colleagues at MIT in the US came out with this amazing announcement about interesting stuff on Venus. And we've kind of hinted there at what it is. It's not really life, but Terry's going to go into that in a lot more detail. But from Venus's perspective, this is kind of not a new thought, a new way of thinking or idea about Venus. Patrick Moore, who Terry and I both know and knew quite well before his passing, obviously famous British astronomer. He talked about talking Venusian, and all through the 1950s and 60s, before the initial spacecraft arrived at Venus, and some of the earliest observations of the major temperature issues and other pressure issues, etc., that exist on Venus were well known. There was speculation, because it's Earth's evil twin, or Earth's twin planet. It's pretty much the same size as Earth. And only about 30 million miles closer to the sun. So people were speculating that potentially there could be life under these thick clouds that nobody could see. And that was propagated through not only people like Sir Patrick Moore, who, one of the most famous astronomers in British history, but even eminent astronomers like Carl Sagan were thinking along these lines. And then the spacecraft arrived, the space probe arrived, the Mariners from the United States and the Veneras from the Russians. And obviously, when the Russians first attempted their landings there, the spacecraft were being destroyed. They were being crushed out of all existence, and they didn't know why. And then they worked out why, and it was basically that the atmosphere is so dense it would crush any normal spacecraft anyway. That most of it is sulfuric acid. It was what rains from the planet, and it's a very, very dense kind of carbon dioxide, nitrogen atmosphere, but raining sulfuric acid. And then the surface temperature is in excess of 450 degrees Celsius. So not only would you be melted out of existence and crushed out of existence, you'd also have to contend with acid rain. So in terms of anything on the surface of Venus, the Venera spacecraft landed there in the late 70s, early 80s. The Russians also put some balloons in the atmosphere on the Vega spacecraft. They basically proved that on the surface, forget it, it's game over. But the Magellan spacecraft and various other spacecraft that visited the European Space Agency's Venus Express have done some amazing work in terms of mapping and showing that there's potentially still active volcanoes, all sorts of things going on. But this announcement really took a lot of people by surprise. And without further ado, I'm going to hand over to Terry, because this was a big one, wasn't it, Terry?
Yeah, absolutely. I got advance notice that there was going to be this major announcement. We didn't know what it was. The secrecy was pretty good up until that morning. The interesting thing about Venus, as you say, is it's everybody's idea of hell, if you believe in hell. Unbelievably hot, unbelievably dense atmosphere, and a corrosive, poisonous atmosphere. But the interesting thing is that we think it wasn't always like that. It very may well have started off much more like Earth, with moderate temperatures, possibly with water. In other words, it is possible that life could have evolved there. They think it's only roughly in about the last 600 million years that a runaway greenhouse effect, which is obviously a salutary warning for Earth, but a runaway greenhouse effect drove the temperatures way, way up. But if life had already developed or evolved or even been transported by panspermia or whatever to Venus, those changes took place relatively slowly, certainly in Earth-like terms. So any life that might have been there could have had time to evolve to the changing conditions, the rising temperature, the increased acidity, and the pressure. So we know from Earth that microbes can survive in incredibly hostile environments. The volcanic acid springs in Yellowstone, for example, are an amazing example. But if there could be life there, it is almost certainly, as you say, high up in the clouds. And there's absolutely no reason why it couldn't be there. Now, to get on to the science of the latest discovery, they discovered phosphine, which is basically a very toxic gas. Well, it's only toxic really if you're a person or a being that's
air
allergic
breathing.
to it. Yeah, there are other organisms that could thrive on it, but the interesting thing is that apart from producing it in factories with specialized equipment, the only way that we know that that gas can be produced is by biological activity, basically anaerobic bacteria, bacteria that thrive without the existence of oxygen. And they didn't discover very much of it there, but the signature is absolutely clear. There are about 20 parts per billion of phosphine in the atmosphere of Venus. The other interesting aspect is that it could not survive for very long in that very hostile environment. The sulfuric acid would break it down very quickly. So it must be continually produced for it to be there at the moment. And this is where it gets really interesting. It's being produced and detected it, first of all, with the James Clerk Maxwell Telescope, and then they did follow-up observations using ALMA. There's absolutely no doubt that it's there. It is being produced constantly. And without going into too much detail just at this point, the best explanation, and in fact the only explanation that the astrobiologists and the biochemists have come up with, is by biological activity from basically anaerobic bacteria. It's possible that it could be something else, but in terms of the Earth environment, that's the only way that we can think of doing it. Now, of course, what will now happen is that everybody in the field of astrobiology will come up with, try to come up with alternative explanations as to what could be producing the phosphine. That's the way science works. If they can't, then it's very, very likely that it is basically biological activity. We'll not know for certain until we actually send probes there. And interestingly enough, there's a proposal just announced recently to send a probe into the atmosphere of Venus to look for microbial life in the clouds. That might be able to give us a 99% definitive answer, but probably not until we actually get samples from the atmosphere back to Earth and study them in a laboratory, could be absolutely sure. But to come to the crunch point, if this is life on another planet, it's what we call abiogenesis. In other words, life has developed independently from what's on Earth. And that means that if it can develop elsewhere in the universe, life on Earth is not unique. And that opens up the possibility of much more advanced life, for example, developing on planets or other environments where it's more conducive to the development of advanced life.
It's really interesting as well, some of the points you hit on there. I mean, the first one that I found really interesting is the notion of Panspermia.
Yeah.
This is a theory that basically life was kind of brought to Earth either by cometary activity or potentially asteroidal activity in some dim distant past. Now, the thing is with Earth, we know that life kind of started out on Earth around about 4 billion years ago in microbial, very low level form. That's what we know of in terms of the oldest potentially dated organisms, between 3 to 4 billion years ago. If Venus was habitable, as in more conducive to life, up to potentially, as Terry said, 600 million years ago, the Earth was being bombarded by extreme impact events all through that period of its history, which could have potentially, and I'm not saying this is the mechanism, but that could have potentially, known the way that asteroids and asteroid impacts work. We pick up loads of Martian asteroids, for example, on the Earth's surface. We've only got one potential example of a Mercurian asteroid or meteorite on the Earth's surface, but there's loads of Martians, loads of lunars. And the concept of something hitting the Earth and knocking off organisms from the Earth, which then arrived on Venus surface at some point in the past, that is a really interesting kind of potential theory for this. But it could have developed completely independently. We don't know the whole solar system was being bombarded out of existence, during the late heavy bombardment around about 4.5 billion years ago. So who knows what was happening there. The other interesting point that you were talking about there was this detection up in the atmosphere. So these microbes, or this detection, is around about 32 to 37 miles up in the atmosphere. So it's a lot more temperate than the surface, where the pressures are just extreme. This development of life and the potential for it to have almost developed a shielding mechanism of some degree to protect it against the sulfuric acid is extremely interesting. And there's been research in Earth's atmosphere at very high altitudes that's shown that there's microbial life up at extreme altitudes on Earth. And you only have to look at the extremophiles that they've discovered in the lake systems, some of the really acidic lakes on the Earth's surface, to show that life is very adaptable. So whilst the lead scientists from this, and it was really fantastic to see so many female lead scientists on this, were being almost chemsplained to, and that's my favorite term ever, where all these men were coming in and saying, it's not this, and then talking about, obviously phosphine detection in Jupiter's atmosphere and Saturn's atmosphere, and they're saying, well, there's a life there as well. No, they're completely different processes, and we don't understand. Science doesn't yet understand all of the chemical processes that are occurring in planetary atmosphere.
Absolutely.
So it's one that's really open to debate. And as you said, Terry, the mission, so NASA have got the Da Vinci mission kind of in their decadal planning, as it were, which should be really interesting. But even hotter than that is, and we've talked about these guys before, Rocket Labs down in New Zealand. So Peter Beck and his Rocket Labs team, and they've been launching like small launches now for quite some time, very successfully. They've only had one launch failure out of about 14, 15 launches. They've got plans to send a spacecraft to Venus. And from what Professor Sarah Seeger at MIT was saying yesterday, there's 3 kilograms of payload space that are left. Now, looking at what's happened over the past 20 years, you're looking to look at Beagle and some of the amazing scientific instrumentation reduction that happened on that to get that into something the size of a coffee table onto the surface of Mars. You think, well, 3 kilograms may not sound like a lot, but if they can jam in something that could do some really good science, as an aside to all the great science that obviously is going on that mission, I think, within the next few years, we could get some really intriguing results. And it is, the scientific team are fantastic. I mean, they've said, yes, we don't know what's going on here. Rip our results to pieces. They've literally opened it up and said, if you've done something wrong, we need to know. Tear us to shreds. So it's a great example of science in action. And you only wish that other aspects of society, like politics, for example, were as open and transparent and said, yeah, we've got it wrong. Tear us to pieces. So watch this space, definitely. But Venus, it's one of those beautiful planets. We had it up in the low sky for the evenings earlier on this year. It's up in the mornings at the moment. It's beautiful to see. It's one of those things when you look at it through a telescope, you see the phases. And if you've got good telescopes and cameras and narrowband filters, you can see the clouds actually moving. It's wonderful to look at. So definitely watch this space.
Sorry, just 2 further points on that, on the adaptability of organisms. Succulents, cacti, for example, are relatively resistant to sulfuric acid because they have a coating on the outside. And if you've ever been unlucky enough to have mare's tail or horsetail, which is a very primitive plant in your garden, it's a very difficult weed to destroy, because it has a silica coating on the outside. So you put on even the most powerful weed killers and they simply don't penetrate in to destroy it. You need to actually sort of crush the stalks to expose the inner part before you put a weed killer on. So just a very simple example of how some plants on Earth are very, very resistant to things that kill other things.
Well, that's the thing. You only have to go into science fiction as well. You look at Ridley Scott's Alien movies from the late 70s and obviously the movies in the 80s, where again you had a life form that became extremely resilient. And that's science fiction, but who knows? We're one pale, tiny little blue dot in one solar system orbiting one star at 250 billion in one galaxy. So who knows? It's fascinating, really is. Coming closer to home. So China, our good friends over there who are doing all sorts of fantastic, and from a scientific point of view, they are actually doing some great science. China have obviously got missions heading towards Mars. So aiming for a really interesting multifunction mission to Mars, which we talked about previously. This one's a bit more interesting from a what's happening up there defense kind of perspective. So China can we say, notorious for borrowing ideas from from other nations. And the Long March rocket, I mean, it's a very successful launch system. This is interesting for many respects in that they've launched this kind of copy of the NASA X-37B. So the X-37B, if you don't know, is this kind of mini space shuttle that is uncrewed, nobody on board, and it can kind of go up into space and stay there for years. It's obviously performing various functions for the US military that we're not supposed to know about, but you can imagine what they are in low Earth orbit. And then it kind of comes down after a few years, lands, and produces scientific results or defense results for the US military. So China now, despite their denials of what this was, have launched something similar. And the reason I say despite the denials is that Planet Labs had an overflight over one of the runways in China and managed to capture some images just after this thing touched down and landed. Not very high resolution, but enough to discern that there was something there that shouldn't be there and its associated support vehicles. I find this really interesting because China are really accelerating their development in all aspects of space, like from the defense side, from the scientific side. They've got one of the most impressive launch systems in the world in the Long March launches that they do off a ship. So as a company in the UK called Black Arrow, who have been looking at this for quite some time now in terms of researching launching off basically a converted dry bulk carrier, which is a large ship. China are doing this. So they're launching from barges already. And obviously where they're launching in the China Sea, it's, the sea state in terms of the wave heights, etc., isn't very extreme when they're doing their launches. But they have had lots of success with this. And it opens up the possibilities of all sorts of different launch positions. If you're thinking of launching into equatorial or polar orbits, being able to launch from a ship, I think, is really interesting. But being able to launch top secret space planes on one of these rockets, potentially off a ship in the future, I think is really fascinating. And you've got to kind of doff your hat to China in that they've been quite open from the scientific perspective, but I think with this, a little bit lesser. I don't know, Terry, what's your thoughts on this?
Yeah, just on their capabilities for launching, you may be aware it's a very contentious political subject, but they're developing bases in the South China Sea, in territory that is disputed by Vietnam and Philippines and others as well, much closer to the equator than the mainland of China. Now, these are basically small atolls and sandbanks, but they've built a big runway in one of them. It could well be that they would use a site like that for launching to equatorial orbit. But as you say, the Chinese space program is probably developing faster than any other major country at the moment. And as you say, watch this space.
Yeah, I think the islands that you refer to, I mean, there's all sorts of defence interests in that don't really want to go into. But yeah, it's very contentious, and I'm just hoping now that moving forward, that what China are doing as opposed to Russia. I mean, Russia's hilarious today. The head of Roscosmos, only in the last few hours, has come out, going back to the Venus story, claiming that Venus is Russian and Venus is there. So yeah, good luck with that one, because nobody's really claiming planets. Obviously, people are claiming stakes on the moon and what have you. But yeah, good luck with that one. Unless they've discovered vast amounts of Novichok, maybe in the atmosphere of Venus. Which could be interesting. Hopefully nobody from GRU is listening. But it's very interesting, and I'm really hoping that China, despite the contentious issues from a political perspective with the United States, are really going to progress this from a scientific standpoint. I'm really interested in this. It's good stuff. And their trajectory, I mean, Terry will know more about this, but the trajectory that they're going with human spaceflight is really following the Mercury, Gemini, Apollo.
Yep.
Kind of what they're doing, like small mission, one person, small mission, slightly bigger mission, two people. It's following that, isn't it, Terry?
Yep. And of course, they're going to intend to develop their own space station, which may be eventually the only space station in orbit, because the ISS, it's sort of on an extended lifeline at the moment, but the plans are not to maintain it indefinitely. The United States in particular is very reluctant to keep putting money into it. So it could be that not only the East is red, but space is mainly Chinese in decades to come.
I think once Congress get wind of that, because we were kind of, one of the ideas we were talking about for the show this week was congressional budgets, and Congress have already kind of scraped NASA's budget back. Yeah. So it'd be interesting to see how Congress react if and when China do get a large orbiting space station up there, as to whether or not they are going to say, well, we need to do something about the ISS. And we've got commercial interest, you've got SpaceX, you've got Blue Origin, you've got Bigelow, you've got all sorts of different companies. Bigelow are obviously testing their habitat on the ISS as we speak. So the potential, with it being such a large structure, and it can be maintained, it's proven to be maintainable, whether or not commercial space say, well, okay, if NASA don't want it, if the US government don't want it, then strip all the assets that you think are, you know, something that we may not need out of it, but then leave it up there in a kind of almost like a Skylab type manner, but hopefully not in a Skylab type manner in terms of deorbiting. Because, I mean, this thing costs $200 billion. Yeah. You really don't want to turn it into a very bad, rusty Pacific dive reef. That's,
and you also don't want it coming back down to Earth under control, because there's a heck of a lot of metal in that.
There's a lot. Yeah. We're talking about a football pitch.
Yeah, you do need to put it up into a safe orbit, or else deorbit it safely. And I don't know if they could control something that size accurately enough to say, yes, that'll definitely come down the Pacific Ocean. It'll probably break up on the way down, and different parts come down different places.
Yeah, they'll probably aim it for the Tonga Trench. My biggest fear, though, is looking at the current debris statistics. There are 13,000, and quote me, please, anyone who's listening, like, correct me if I'm wrong, but the last I read was 13,000 collision avoidance maneuvers, not for the ISS, but in general, per month happening right now. 13,000, right? They're estimating that within the next 10 to 15 years, that number is going to go up to 50,000 collision avoidance events. Now, if you've got something the size of the ISS, that's a big thing, and they move it all the time. And the astronauts, on several occasions over its lifespan, have had to go and hide in basically a Soyuz return capsule on the off chance that that thing gets hit and then taken out completely in a gravity kind of style. So yeah, it's watch this space, as we keep saying it. Definitely one. So that brings us nicely on to some happier news, a bit closer to home. So these guys, Sky Roarer, I like them a lot. They are quite a young company, what's called an SME, a small and medium-sized enterprise, based up in Edinburgh. And they're kind of managed and have got some interest in Ukraine. Their CEO is a Ukrainian chap, Vladimir, really fun guy, really interesting character if you've met him. And they've got some great public outreach people, some of whom are involved in other things now. Daniel Smith, who runs Astro Agency, who do some great podcasts and stuff as well. Really interesting kind of group of people. Quite a small team based up in Edinburgh in Scotland, but Scotland's really thriving in terms of its space aspirations at the moment. You've got Clyde Space, you've got multiple potential launch sites. You've got Spaceport 1, you've got Western Isles, Shetland, Sutherland obviously is happening at the moment with the UK government backing. You've got Prestwick Airport. So there's lots happening up in Scotland, which makes this all the more interesting. So Sky Roarer can't get launch permission for Scotland. They tried to launch it when it wasn't great in terms of what happened from Scotland, where they upset a few people at the Coast Guard Agency and local Coast Guards. So they've done the right thing, and they've gone to somewhere that has got launch regulation and provision, and that's Iceland. Now, Iceland's most famous, I guess, for being kind of the second landing spot of the Vikings back in the Viking era, when they were hopping over between Iceland and Greenland and then North America. For anyone watching in America, Columbus did not discover North America. It was discovered several hundred years before Columbus by Eric the Viking and Leif Erikson. I think it's Leif Erikson, Leif, his son. Basically, there's evidence now up in Newfoundland to that effect. But Iceland's this really interesting kind of almost barren wasteland in some respects, but great for launches. It's in the right latitude for polar and sun synchronous launches. And their space agency, for want of a better word, which didn't really exist only a couple of years ago, in the period of less than a year, managed to get complete launch frameworks, launch regulations in place, and enabled Skyrover to do a suborbital. It only went up to about 26 kilometers, which is still an achievement, launch to test their avionics and their flight systems, etc. Really, really interesting. Sadly, the Micro X launcher, which they used, they were due to recover it from the ocean. They weren't able to do that. They were still looking, last we heard, and the Icelandic search and rescue teams were helping as well, and teams from Skyrover. So they did lose it, but they got a lot of scientific data back from it. And I think these guys are definitely one to watch, because they kind of buck the trend, as it were, with launch, in that if they can't get something that they need to do to progress their development, and they're doing a very measured set of developments. They've gone from really small launches at very low altitude up to these kind of next stage up, and then they're going up bigger and bigger until they get to the Skylark XL, which is their big kind of orbital provision vehicle. And they are doing things right, but they just can't get a launch in the UK. Which is a real shame, given that most of the supply chain and everything that they need potentially could come from the UK. I mean, they've got production facilities, as I said, in the Ukraine, but I really like these guys. There's some interesting things that they do, and there's some interesting ways that they do it, which may not be to everyone's taste, but they're definitely a company to watch. I don't know if you know much about them, Terry, but
just a bit. Just to be politically correct, I would have to say that North America was actually discovered by the first people that migrated across the Bering Strait about 10,000 years ago, long before the Europeans.
Long before the Vikings got there.
The only thing about this, as you say, it was just a test of a relatively small rocket, but they are building up to a much larger XL and so on. But the interesting thing is that it is basically a mobile launch facility. So it was relatively easy for them to set up in Iceland. If they do ever get permission in the UK, they can go to Shetland, they can go to Sutherland, they can go to anywhere basically where there's somewhere simple. They are very adaptable and forward thinking in that respect. So more power to them.
Absolutely. And it kind of aligns a lot with the sustainability and the environmental kind of remit that the UK government are pushing on space at the moment, in terms of the propellants that they're using are very environmentally friendly. They're not requiring cryogenic cooling. The launch system, again, it kind of almost harks back to Wernher von Braun with the V2 days, in, obviously during the course of the Second World War, where we had the ability, well, Wernher von Braun's team had the ability to launch a rocket pretty much from a mobile launcher anywhere. So they were moving around the forests and essentially launching attacks against the UK from anywhere they felt like. And it's almost harking back to that. And obviously the V2 was the first thing. Great pub quiz question, if you don't know. First thing to actually cross the Kármán line wasn't Sputnik. The first thing in space wasn't Sputnik. It was a V2 rocket. But anyway, and the first things in space in terms of living organisms were fruit flies and the nose cone. But anyway, it's a great pub quiz kind of question. It's definitely worth watching. And I think if they get this right and the mobile launch facility is able to handle the largest of their rockets, then, as you said, they could literally go anywhere. I mean, they can ferry across to Norway, Sweden, who are two other countries that are vying to be the first in Europe to get a launch, or to Iceland. So again, it's one to keenly watch, I think, if you're interested in the nascent UK launch capability and what's happening with that. So all power to them, definitely. Which brings us nicely to our kind of closing story with a beautiful picture of a star cluster. Space Week, World Space Week is coming. Terry, I know you've been massively involved in this in the past in terms of Ireland. Your
not
thoughts?
As much as I would have liked, but this year, as you say, World Space Week, marking the anniversary of Yuri Gagarin, first man in space. There are certain other people think otherwise, but anyway, 4th to 10th of October. Now this year, unfortunately, just like everything else, a lot of activities are being curtailed by the COVID-19 restrictions. There aren't as many events this year as there were last year, but if you check online, check with your local astronomy club or something, there's still time to organize events. There are some in the UK. But if there's nothing near you, there's nothing to stop you yourself just doing your own little bit for World Space Week. First of all, we'll mention this maybe a bit more later. Go and have a look at Mars and think just how many spacecraft are there at the moment, either on the surface, defunct, not working anymore, or still active, other ones in orbit around it from, 4 different nations or 4 different agencies launching. And just think what we are doing and how as they say, rocket science. This is rocket science. We can do amazing things, and the success rate of missions to Mars is not as good as it could be, but it's better than, for example, the probes that were sent to Venus for the reasons that we mentioned earlier. Also, when we come maybe to look at the look up section, go and have a look at Venus yourself. That means getting up early in the morning, about 4 a.m. up to dawn, and think there in the atmosphere of that planet, there may be other life. So even if there's not an activity that you can actually take part in physically, you can do your own thing, or there'll be various things that are available, I'm sure, online. So mark Yuri Gagarin's historic flight during the week, 4th to 10th of October. Use the internet and do whatever you can and participate in whatever way you can.
That's the beauty, actually. It's one of the positive things I think that's come out of COVID. There's been, I mean, we're obviously doing this broadcast with our amazing friends at the Space Store, and that's fun. Yeah, we're loving this. But there's so much going on. I mean, Space Store themselves do so many other events all through the course of lockdown. They've been hosting talks now since pre-lockdown, actually. But there's loads and loads going on, so you can just jump in on anything, anywhere in the world, in effect. The massive International Astronautical Conference, which is one of the biggest space engineering and spaceflight conferences on the planet, which normally takes place in Washington, is online this year. So you can kind of just jump in and say, we'll take part, you kind of have a gander at what's happening with that. And there's so many events. So there's kind of no excuse to either, as Terry said, set one up yourself. Even if it's just register your own home observatory. Anyone can do a Zoom broadcast. Anyone can put a broadcast up, make sure that it's secure, broadcast via YouTube or other streaming systems, and just get people involved. And you can tell the World Space Week kind of community and the organizers that you're doing something. And it could be a simple broadcast, connecting up a camera to your telescope and looking at an object like Mars, as you said. If you look at, we now have the potential to look at Venus, and as Terry said, potentially life there, and look at Mars, and there may even be life there. There's methane coming out of Mars that we can't explain. So there could be subsurface microbial life on Mars. There could be atmospheric microbial life in Venus. Who knows what's going on? We've still got Saturn and Jupiter as well to look at. Mm-hmm. So definitely. And it's a great way to kind of celebrate the good part of space. I mean, Gagarin, obviously it was geopolitical, the early days of the Soviet-US space race, 1957 International Geophysical Year, and the Soviet Union as then was beating the Americans into space. But I think since the early 70s, since the Apollo-Soyuz test project, and now with the ISS, there's been a lot more collaboration. So it doesn't matter who's in charge on the ground. It could be some idiot on that side of the world, or it could be some idiot on that side of the world in charge and causing all sorts of political problems. But up there, 100 miles above our heads, or wherever with the ISS, we've had international collaboration now for decades. And it's one of those beautiful things that it doesn't matter. This is why we talked about China, and we talked about Russia a little bit with the veneers and stuff. Science is science, and great science is great science. So the more we can do to kind of communicate that and collaborate that, we think the better. So definitely. So that's another one to keep on mind. We'll talk a bit more about that in the next show as well. But World Space Week is coming up. You've still got time to register. And that kind of closes now with what's up? What's happening? What can we not miss, Terry?
Okay, I've already mentioned Venus. One of the interesting things about it is for you to think just why it is so bright. It is much, much brighter than any other planet, even though it's just slightly smaller than the Earth. And the reason it's so bright is that it's covered entirely by these amazing clouds that we were talking about. And clouds are very, very reflective. So that's why Venus is so bright. It appears either in the evening, and it's called the evening star. At the moment, it's in the morning sky. We call it the morning star. Not a star, just a planet, as we've been saying. If you have good binoculars or a telescope, have a look and you'll see that the phase is a bit more than half. It's round about 66% illuminated at the moment, and that's slowly increasing as its relative orientation to the sun increases. The amazing thing is to think just what might be actually on Venus at the moment. What else is coming up? On the 22nd of this month, it's the equinox, and we move from astronomical summer to astronomical autumn, because the sun will be crossing the equator, going from north to south. We have International Observe the Moon Night coming up on the 26th of September. And again, there may be events organized for that. But if you have even a pair of binoculars, go and have a look at the moon. It'll be just past first quarter then, so you'll be able to see some of the amazing big craters on the moon. Biggest craters on the moon are actually more than 200 kilometers in diameter, which is sort of mind-boggling. And when you think that probably the Earth was also hit in the distant past with objects that created craters that size, they've been totally destroyed due to plate tectonics since then. But you can still see the really big craters on the moon, even with binoculars. Also, you'll be able to see, for example, one particularly bright crater called Tycho, which has rays, bright rays radiating from it. And also Mars, we also mentioned Mars. It'll be at a supposition and closest and brightest to Earth just after our next one, our next webinar in 2 weeks' time. But just watch it even tonight. It is incredibly bright as Jupiter. And the reddish color is absolutely outstanding. The reason for that is basically because the surface is covered in rust. We'll go into that probably a bit more next time, because Mars will be at its best just after our next meeting. But basically, there's loads to see in the sky. If you have time and we're out looking for Venus, have a look at Orion and see is Betelgeuse back to its normal brightness. Some people are saying it's still faint, maybe fading again, we don't know. But there's no shortage of things to look at in the night sky.
Absolutely. And even with a modest telescope, this is one of the beautiful things about looking at Mars, is you can see the pole caps.
Yeah.
You can see the ice caps at the poles really easily, even with like I to look with an old Meade telescope, which was like what they call an ETX90, which is a 90mm aperture, and imaging Mars, you could easily pick up the north and south polar caps on that and some of the larger kind of regions on Mars. A relatively modest large size telescope, you can see Olympus Mons. You can actually see a volcano on another planet that's like 30 plus million miles away. So it's one of those things that definitely have a look for. I can see also we've in the chat we've had some questions in tonight, which is great. Latch has posted in wondering what our esteemed experts thought about the Europa Clipper mission. Planners saying that they may need to find a new rocket, as the SLS, which is supposed to be launching on, may not be ready. This is an interesting subject. So I know people are working on the SLS and the Artemis missions, and there's all sorts of issues with Boeing as the prime contractor, and there's been delays, massive multi-billion-dollar delays and overruns. Europa Clipper is one of these missions that essentially there was multiple phases for this. One of the elements in the past that we're talking about was a ground-based penetrator, so launching, basically dropping something from orbit onto the surface of Europa that was going to kind of dive into it. And there's all sorts of testing on that done in Pendine in Wales, of all places, on the high velocity test track there, where a company called Kinetic, or a big defense company, were looking at all sorts of aspects of supporting a mission to Europa. In terms of SLS, I guess it's one of those things that it needs to happen. NASA need to get back to these large launch capabilities. You've obviously got SpaceX with Starship. SLS itself may be the last bastion of these big, heavy launch vehicles that we ever see in the respect of non-reusable kind of single shot to orbit launch vehicles. It's very expensive. The estimated costs from the SLS launch are in the hundreds of millions per launch. So it's an interesting one, Terry. I don't know what your thoughts are on SLS, but I'm hoping Europa Clipper goes ahead. If SpaceX launch it, great. If Blue Origin launch it, whoever launches it, it needs to happen. This is science, so it needs to happen. The SLS, though, it's one of those things that they've got tie-ins with LM and Lockheed Martin on the Orion spacecraft, which is all ready to go. The European Space Agency is delivering the service module, which is pretty much ready to go. So it's kind of just waiting on this launcher now. But I think the quote was $146 million for the SRBs, the solid rocket boosters on it, which is almost more than a SpaceX launch and recovery. So I don't know, Terry, what
just delays are part of the scenario in space. There are always setbacks. You have to allow for them, basically. I'm not sure just how critical the launch time for the Europa Clipper mission is. It's not just quite as critical as for Mars, because the relative positions of the Earth and Jupiter are not all that, they don't vary all that much from year to year. Obviously, you want it to be going up in time. But when you think of what happened with the Apollo mission and the Apollo 1 fire on the launch pad, which set them back 2 years, and they still managed to get men on the moon before the end of the decade, which was Kennedy's target. So there's always delays. Usually they find a way to work around it, and I'm just hoping that they'll be able to do it in this case too.
I think it's a very good point. It's interesting though that in the days of Apollo, the US budget, the GDP and the budget for the Apollo space program was vast compared to what NASA have got now. And that again ties back into this, the Senate making all of these cuts. So you hope, and this is a big hope, I think, from everybody in the scientific community. You've got 2 major missions in the offing now from NASA in the next few years. You've got the James Webb Space Telescope, $8 billion, massively delayed. If that fails and or the SLS fails, this could spell almost disaster from a NASA perspective. And that to me would be an absolute crying shame, because after years of potentially not doing as much as they did during the Apollo era, and don't get me wrong, they've done some phenomenal work. I mean, the Vikings, the Voyagers, New Horizons, there's been so many incredible missions, all of the Mars rovers. They've done some phenomenal science, NASA. So people like, our erstwhile Orange president saying, oh, well, they've not done anything and they've only started doing things again. That's just bunkum. It's a myth. NASA have done some phenomenal work for decades. But they're really now just getting back to what they can do with human exploration. Don't forget, since 1972, no human being has been more than about 450 miles away from the surface of our planet. That's to repair the Hubble. That's about as far away as anyone's gone. So it's kind of a depressing fact, but in 1969 to 1972, we were going 250,000 miles away and orbiting with the power of a pocket calculator as a computer. So we need to get back to that. We need to get back to human exploration. We need to go on to Mars. So we need Artemis, we need SpaceX, we need all these other companies all around the world, be they commercial or government backed, to really continue with exploration. So I would hope Europa Clipper happens. I would hope that the SLS, if it is delayed, it'll still have missions to do. It's not one of those, it's a spacecraft waiting for a mission. It needs to have the moon. They need to go back to the moon. If we don't go back to the moon, we're not going to understand how to live on Mars. We've not been to the moon for 50 years nearly. So we need to go back and start exploring there again.
You just mentioned Artemis there. That's actually the second part of the question. I don't know whether you saw it there, Nick.
Yep.
So do you want to say a wee bit more about that? There are other options, of course, with Elon Musk and so on, developing really big rockets. If NASA or ESA or the Chinese or the Russians sort of opt out, there's ever increasing development of capacity in the private sector. So I don't know how flexible the program is, but space will continue no matter what. Space exploration will continue no matter what.
I think with Artemis, what the issue you've got the Falcon Heavy, which potentially could put a large payload into orbit. It probably do it as a 2-stage mission, whereas SLS can probably get. I mean, the SLS is quoting at over 100 metric tons into orbit. And the issue is that LM and the European Space Agency with the service module, they've developed fairings and connectors which are designed to fit around the Artemis program. So if there was to be any change, fundamental change, there'd have to be a lot of redesign work, and that's kind of not what you want on the timescales that they're aiming for. 2024, forget it. It's just, if at the absolute best, we'll get maybe a cislunar kind of Apollo 8 style mission by 2024. You're not going to get a lander. It's not going to happen. Essentially, we've been set back. The whole world's been set back a year because of COVID. You've got 2-3 years now with all the budget constraints, etc. Realistically, it'll be a miracle if it does. I think the Artemis program there's more than just the SLS involved here. We've got the Lunar Gateway. We've got a whole series of different things, and there's arguments as to whether or not the Lunar Gateway is a good idea as well. But there's a whole raft of different technologies, supply chains, companies that are really dependent on this happening, because the potential for lunar exploration, both from a scientific perspective, which I think needs to happen again first, but then potentially down the road, going back to Andy Weir, and Andy Weir's second book after The Martian, really good book, it's called Artemis. And Artemis is obviously the sister of Apollo. And the whole kind of commercial exploration of the moon and the potential for what we could do there in terms of science, putting radio telescopes on the far side, putting optical telescopes up there. There's so much that needs to happen. So we need these missions.
And
that's
the moon
pretty
is
much.
always there. It's not going away. So
Yeah.
if they don't do it in 2024, you can do it next year or the year after.
Yeah, it's only moving a few centimeters every year. If you watch Space
Yeah.
1999, that's not happening. Great sci-fi from the 70s. If you've not seen it, go on YouTube and have a look. But yeah, it's moving about that much away. It's about the speed of your fingernail growth a year away from us. And we know that because of the laser retro reflectors that were left there by Apollo. So all you conspiracy theorists, boom, answer that one.
You just reminded me of one more thing you can do for Space Week if nothing else is available. Watch or read The Martian. Apart from the very last bit when he's being rescued, it's pretty good science.
Yeah, it's pretty solid.
It's very, very good introduction to what a mission to Mars might be like in the future.
Absolutely. That and the wind speeds during the first part. Best story ever. We'll just close with this one. I watched that film. I took my kids to see it when it first came out, but I was over at NASA Goddard having a fantastic tour around the James Webb facility and meeting up with some friends because we got involved in the James Webb program. And I've got a very dear friend who worked at NASA Goddard at the time managing the SSCO office called Ed Razak. And hi Ed, if you are listening. Really, really fantastic guy, and spent a few days kind of at his house with another friend of mine, Robert Brand, who's running an Australian program called Thunderstruck space program, who are developing a Mars lander that I kind of conceived as well many years ago. And all I can say is never, ever, ever watch The Martian when you've had a few drinks and you're with a NASA engineer, because it's just brilliant. It's like, that's wrong, that's right, that's good. So Andy Weir did his homework. He did a really great job, and he's a great guy. If you've not met him, he came over to the UK a couple of years ago. He was at Bristol. The really good fortune to meet him, and he's a fantastic guy. So great books. Definitely read The Martian or watch it.
And follow up. Sorry, with Artemis, which by sheer coincidence, or maybe not, was the title of his follow-up book about a man based on the moon in the future. Well worth reading also.
Absolutely. So yeah, definitely lots of things to do during the summer months. Winter's marching on, as we say, the time is marching on for us as well. So I just want to say again a huge thank you to Space Store for regularly hosting us and our occasional rants and lots of fun that we have. I love this. I know Terry does. We're both beaming, smiling through all these shows. We always have a good laugh and a good chat. And we'll see you again, hopefully in a couple of weeks. But good night from me.
Good night. Keep looking up.
Awesome. Thank you so much for everyone who tuned in. Remember, if you haven't watched all of our previous roundups, they're all available to watch on our YouTube channel. So please do head over there and have a watch. As Nick said, our next roundup will be on the 29th of September, same time, same place on YouTube, and we'll see you then.
Okay, bye.
Adios, amigos.
Take care, everyone.
Cheers. Bye. Bye.